Ever pondered how the universe of the seemingly insignificant functions? Welcome to the quantum realm. Imagine a world where you can be in two places at once while shopping for groceries, or where a text message is received even before you have sent it. Sounds magical, doesn't it? That's the quantum realm for you. Quantum physics, the study of the exceedingly minute, explores the peculiarities of tiny particles at levels smaller than atoms. It's an intriguing and odd world that challenges our daily understanding of reality. The guiding principles of this realm, superposition, entanglement, and quantum tunneling, are nothing less than mind-bending. Superposition is similar to having a pizza that's both pepperoni and cheese at the same time, but when you take a bite, it suddenly becomes just one or the other. Next up is entanglement, a bizarre phenomenon wherein two particles become linked. Imagine you and your best friend sharing the same thoughts and feelings instantaneously, no matter where you are on the planet. It's kind of like being at two different parties at the same time, sharing and mystifying immediate connection. Finally, we have quantum tunneling. It's like randomly finding a secret passage through a mountain while hiking, a passage that was supposedly impossible according to any map. These principles may seem like plots from a science fiction novel, but they're real. They make us question our understanding of the world and hint at a range of unimaginable possibilities. The quantum realm is a world where our usual rules resemble fairy tale magic. It's a world that obeys its own set of strange rules, vastly different from the regular world we live in. It encourages us to change our viewpoint and embrace the quirks of the universe. So the quantum world operates on its own set of peculiar rules, different from the regular world we inhabit. You might be wondering, how does quantum physics relate to artificial intelligence? Let's dive in. Quantum physics isn't just about unraveling the mysteries of the universe. It's also about revolutionizing our technological capabilities. At the heart of this revolution is quantum computing. Unlike classical computers that process bits of information as either 0s or 1s, quantum computers use quantum bits or qubits that, thanks to the principle of superposition, can exist in multiple states at once. This allows quantum computers to process vast amounts of data exponentially faster than classical computers. Imagine the possibilities when this quantum advantage is applied to artificial intelligence. It can significantly enhance AI capabilities, making it more efficient, more powerful, and able to solve complex problems that are currently beyond our reach. And there's more. A new field called quantum machine learning is emerging at the intersection of quantum physics and AI. It aims to use the principles of quantum mechanics to improve machine learning algorithms, potentially revolutionizing the way we understand and process information. So quantum physics isn't just about understanding the universe, it's also about enhancing our technological capabilities, including AI. Imagine a cat that's both alive and dead at the same time. Sound puzzling? Welcome to the concept of quantum superposition. Quantum superposition is a fundamental principle of quantum mechanics that allows particles to exist in multiple states at once, that is, until we decide to measure or observe it. This concept is famously demonstrated by Erwin Schrödinger's thought experiment, known as Schrödinger's cat paradox. Picture this. A cat is placed in a box with a radioactive atom that has a 50-50 chance of decaying within an hour. If the atom decays, it triggers a mechanism that releases a deadly poison, killing the cat. If it doesn't decay, the cat lives. Now, according to the rules of quantum mechanics and the principle of superposition, the cat is both alive and dead at the same time until we open the box to check. This might sound absurd in our everyday reality, but in the quantum world, this is business as usual. It's not that the cat is in a state of limbo, undecided between life and death. It's that the cat is in a superposition of states, both alive and dead simultaneously, until we make an observation. This paradox stretches our understanding of reality and forces us to accept that in the quantum realm, things can be in multiple places at the same time, or in this case, both alive and dead. So until we peak, Schrödinger's cat remains both dead and alive. The act of observation determines its fate. What if you could affect an object millions of light years away, instantaneously? Sounds like magic, but it's quantum entanglement. Quantum entanglement is a strange phenomenon that only occurs in the quantum realm, a world that follows rules entirely different from our everyday reality. This extraordinary concept suggests that two particles can become so deeply linked that they share the same existence. This means if you were to measure one particle, you would instantly know the state of the other, no matter how far apart they might be. Imagine having a pair of dice. Ordinarily, if you roll them, they would land on random numbers. But in the quantum world, these dice are entangled. When you roll one die and it lands on a 6, the other die, no matter how far away, will also land on a 6. It's as if the dice are communicating at a speed faster than light, which by Einstein's theory of relativity should be impossible. This is what Albert Einstein referred to as spooky action at a distance, a phrase that captures the baffling nature of quantum mechanics. Despite his unease, countless experiments have proven quantum entanglement to be a real phenomenon, even though it defies our intuitive understanding of the world. But don't worry if you find it hard to grasp. As the great physicist Richard Feynman once said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." So, entangled particles are like cosmic twins, mirroring each other's state across vast distances. What if you could walk through walls? In the quantum world, particles do just that. Welcome to the fascinating concept of quantum tunneling, where particles perform what seems like magic tricks, defying the laws of classical physics. Imagine trying to roll a ball up a hill, but it doesn't have enough energy to reach the top. In the world as we know it, the ball would simply roll back down. But in the quantum world, it's a different story. The ball, or in our case, a quantum particle, could suddenly appear on the other side of the hill, even without the necessary energy to get over it. This is quantum tunneling, and yes, it sounds like something straight out of a science fiction novel. So, how does this happen? Quantum mechanics tells us that particles don't exist in one state or another, but in all possible states at once. This means a particle has a small but non-zero chance to be on the other side of an energy barrier, even if it doesn't have enough energy to surmount the barrier. It's as if the particle takes a shortcut through the barrier, something that's absolutely impossible in the classical world. This isn't just theoretical musing either. Quantum tunneling has real-world implications. It's the principle behind the operation of scanning tunneling microscopes, which can image surfaces at the atomic level. It even plays a role in nuclear fusion, the process that powers the sun and other stars. But it's not just about scientific applications. Quantum tunneling also challenges our understanding of the universe and reality itself. It shows us that on the smallest scales, the world doesn't operate by the rules we're used to. It's a world where particles can be in multiple places at once, influence each other instantly over vast distances, and yes, tunnel through barriers. So, in the quantum realm, particles can defy the impossible and tunnel through barriers. You might be wondering, how does all this quantum weirdness affect me? Right in your pocket, quantum physics is at work. It's integral to the functioning of semiconductors in your smartphone, the lasers in your Blu-ray player, and even the LED lights illuminating your home. And it doesn't stop there. Ongoing research is poised to revolutionize computing and telecommunications, making them faster and more secure than ever before. So, while the quantum realm may seem strange and distant, it's closer to your everyday life than you might think. Did this journey into the quantum realm spark your curiosity? Are you ready to dive deeper into the mysteries of the universe? If you enjoyed our exploration of quantum physics and its impact on your world, don't forget to like this video and subscribe to our channel. By doing so, you're not just supporting us, but also fueling your own knowledge. Stay tuned for more fascinating insights into the realm of the incredibly small, incredibly strange, and incredibly influential world of quantum physics. Remember, every click is a step closer to unraveling the mysteries of our universe. So what are you waiting for? Dive in.